So, hello everyone, how are you all? I hope you all are fine and safe. Well, again, welcome back to Quantum Mathematics. I'm Aman, just welcoming you all to a new amazing video in which we are gonna be doing projectile motion. Well, let's take a pause here for a second, guys. You know what? My channel's name is Quantum Mathematics. It doesn't mean that I don't teach physics. Actually, I don't teach it. I just want you to feel physics. Actually, I just want to show you the beauty of physics, right? As well as mathematics, right? And you might have noticed mathematics, but let's just talk about physics. Although I have uploaded a video on astrophysics named, I think, our universe. So if you want, you can check that out. Actually, in that video I have talked about some facts, which is incredibly unbelievable about universe, about our universe actually, or you can say our observable universe. So for that case, if you want to see any video, so you can consider watching that video. And let's just talk about projectile motion here, right? So basically, what's projectile motion? It's a some sort of, it's a motion actually. And to just understand this, we are gonna be like taking all the things that are necessary to understand projectile motion, right? Okay. And basically in this video I'm not gonna solve any problem. It's up to you. And I am not a problem solver actually, that I want to make sure that I want to be. I'm just a guy who wants you to just take a look at the real physics or mathematics, right? So so let's just talk about the projectile motion. Okay. So projectile motion, and in India, like where from where I belongs to, it basically comes in 11th standard, right, in physics, right? Okay. So let's just talk about this. And yeah, I'll make sure that I will explain you each and everything in detail, that you won't get any kind of confusion regarding the theory, or you can say the visualization of projectile motion, right? So basically, when a body is projected, what is a projection? Well, a projection is some sort of, you can say, when when you throw something, right? When you throw something, let's just talk about this. So basically, when you are throwing something, let's say you are standing right over here, or maybe you can say you are standing right over here, and this is your hand and you are throwing a ball, you can say. So this ball will be following this path, right? Okay, let's just read this once, and I'll explain it to you. So when a body is projected in effect of gravity, obviously at each point, that ball is being like, is in effect of the gravity towards down, right? So yeah. So basically in such a manner that its path is parabolic. So basically what's parabola is, this is a parabola, you can say, or this is upward parabola and this is downward parabola. So basically projectile motion is a downward parabola, that is, that follows a path. You're right. Okay. Is called projectile motion, right? And projectile motion is an example of 2D motion. Oh well, let's just not talk about this 2D and 1D motion. Let's just talk about this projectile motion. Okay. So here we are having two types of projectile motions actually. The first one is oblique angular projectile motion, and this is horizontal projectile motion. So this is your oblique and angular projectile motion. Actually, what's angular? It's, you can say, it's the body is being thrown at some angle. You can say this is your angle theta, right? So yeah. Okay. Now let's just talk about this graph, or you can say this image. So basically, when you throw a ball, so yeah, when you throw a ball, so basically you are trying that ball to be like thrown in some this direction, right? You are trying to just this ball to be moving some sort of upward, right? And right. So basically that ball have initially and speed, or you can say a speed inside this like straight direction, right? Basically from this to that direction. So that's why this is your initial velocity, you can say, right? So basically your initial velocity in this direction isn't in that, actually that direction, right? Okay, so basically yeah, this table is like directing some, you can throw, yeah, you can, yeah, so basically yeah, something sort of that. And now let's just do we need to read something this? So when a body is projected in effect of gravity in such a manner, it's called projectile motion. When a body is thrown at an angle from horizontal, then its motor under gravity is oblique projectile. Oh well, it's definitions, dude. I don't want to just learn or memorize those definitions. Okay, now let's just talk about this. This is very important actually, and I need to use pen here. Okay, basically let's just consider a rectangle, right angle triangle, you can say. Yeah, I'm sorry, not rectangle but a triangle, I'm so sorry about that. Okay, so basically let's say that this is your u, so this is your u, right? Okay, and let's say this is your theta angle, and now let's say that this is your x and this is your y. We know that, like we know that we know that x over u is sine theta. So from here we can say x equals u times sine theta, right? And if we talk about y, so y is gonna be like u times cosine theta, right? So basically it's u times sine theta and it's u times cosine theta. And exactly we can say that this is exactly to this here. Basically I can just yeah, so the if the length of these two lines are equal, so this is also your u sine theta, right? So basically yeah, so here it is, actually this is your u sine theta and here is your u cosine theta, right? Okay, so basically yeah, actually it's important, actually it's, I think it's called vector I'm not sure about that. It's been 2.5 years I think since I just learned it, since I studied that actually. Okay, but now I'm just explaining it to you. Okay, okay, now let's just talk about this. Okay, so we are here actually for x-axis. So basically here it's your x-axis, and for our projectile motion this is your x-axis and this is your y-axis. So for x-axis, let's look. When you try to divide this u in terms of u sine theta and u cosine theta, so it's u cosine theta, right? So basically here the velocity which is taking this ball in like horizontally on the right hand side is the vector like u cosine theta. So this is the velocity which is taking the responsibility of this ball to be like reaching here, like on the right hand side on the x-axis, you can say. And if we talk about the perpendicular, so it's the velocity of u sine theta which is responsible to reach this ball as much as to the maximum point, right? So basically this is the maximum point up to this ball, like till the ball reaches, you can say, right? So yeah, I hope you guys are like understanding these things. And yeah, we'll just take a look at all these things again, but now I'm just explaining to you to just be careful, right? Yeah, we're just gonna take about that, we're just gonna take a look over at all those things carefully, don't worry about that. So yeah, so ux, right, like basically x is representing your x-axis, right? So it's the velocity which is taking the responsibility is u cosine theta, and for y it's u sine theta. Okay, so here your ax, it's acceleration, right? So basically ax is 0 because there is no acceleration, it's just the force, or you no, okay, wait a second, it's just the velocity which is just taking this, and this is your u cosine theta, so there isn't any acceleration inside, like on the, you can say on the x-axis, but constantly there is a force, or there is an acceleration downward which is being applied to the object at each point, that is negative g, and negative g is just representing that it's in the downward direction, right? So it's negative means downward, right? So yeah, so for that case, for you to get understand, that's why it's just written over there. Okay, so basically since x ax is 0, so f in x is also 0, and the gravitational force is being applied to the body in y direction, which is downward, right? So fy is minus mg, and these are the formulas actually, right? So yeah, it's just ux equals ux, I'm sorry, vx equals ux plus axt, and so for all these things. So yeah, okay, now let's just talk about this this figure. Actually, this is you can say important, right? Projectile motion, a vector perspective, right? So let's just talk about this. So basically, let me just zoom into it actually a little bit. So this arrow, like this green arrow is representing the y-axis, and this red arrow is representing the x-axis, right? So basically, this ball is like, let's say it's I think, I'm not sure, this is your baseball, I think, I'm not sure, I'm so sorry guys if I'm wrong here, but okay, let's say a ball. So you just thrown it into the air. So from here it's having all the that, like all the you can say velocities, both the like ux and uy here as well, but at the maximum point, look, this is the maximum point of this ball. It means that uy has done its work, and that's why there isn't any velocity on the upward direction, because if it is, then it's not the highest direction. But if it is the highest point, that's why there isn't any velocity which is taking the responsibility to taking this ball any further upward. And that's why we are here, that the velocity, like this velocity is being represented to this one, like this is now gonna help us to drown this ball, or you can say to fall this ball respectively. So that's why it's like in the I'm sorry, you can say in the downward direction and downward and so forth, yeah. And yeah, that's how it's work. So on vertical motion at the top, so basically it's the top, and projectile motion is a combination of two motions actually, this one and this one, right? And here is your g acting downwards, and here it is written that slow down as it goes up. Okay, okay guys, let's just move on from here actually. Now we are done with the projectile motion. Actually, how does it works, right? Okay, now let's just talk about the equation of path. So basically, this is your path, right? This is your downward parabola, as I just explained it to you in the like you can say beginning of this video. Okay, and this is your y-axis, this is your x-axis, and let's say this is your at a point P. Let's say at a point P. So at time t, particle is at point P. So let's just assume that here t equals 0, right? So basically t equals 0, and this ball took t time to reach up to here, t equals t, right? So basically reaching from here, from this point to this point, ball took t times actually. So that's why here it is written at time t, particle is at point P, right? So for x-axis, we have x equals ux times t plus half ext squared. And since ax is 0, right, as we have like already understood it, so we can plug it back over here, and finally we are having x equals ux times t, and ux was u cosine of theta, right? So x equals u cosine theta t, and from here you can isolate t as x over u cosine theta, right? So basically let's just assume that it as the first equation. And now let's just talk about the y-axis, right? So y equals uyt plus 1 over 2 ayt squared. And now let's just plugging back, uy is u sine theta and ay is minus g, right? So basically plugging these back into it, so it's gonna giving us y equals u times sine theta times t and minus 1 over 2 gt squared. And from here we can say, yeah, we can plug this t right over here actually, and here as well. So that's going to be giving us from equation 1 and 2 y equals u sine theta, and this t is x over u cosine theta minus 1 over 2 times g, and t is x over, like t squared is x over u cosine theta whole squared. And from here we can say this u cancels out successfully, and we are having x times sine theta over cosine theta, which is tangent theta, and we have this gx squared minus gx squared over 2 u squared cosine squared theta, and this is the equation of trajectory actually, right? So basically you can say the equation of the path, you can say, right? And yeah, and since it is the parabolic path, that's why we are having some x squared here, because we know that, well, I'm not gonna just memorize you actually, but yeah, okay. So yeah, now let tangent of theta is a and b equals this. So yeah, this is exactly representing the parabolic path actually, an equation of parabola. So yeah, we successfully had proven this one, and if we are gonna be like knowing what is r, and here r is range, and we'll get to know about this in a while. So from knowing r, we can just do some manipulations, and we'll just get back to here as well from that formula. So let's just move on. Okay, so yeah, now let's just take a look at this image. Yep. So basically here you are acting u sine theta, and we have u cosine of theta, and this is the point of projection, right? And we are having the u as some sort of there, and this is your theta, and yeah. Okay, so here like between these the top of projectile and point of projection, we have the alpha, that is, you can say it's an angle which is greater than 90 degree actually, because it's still moving upward. And for here we are having less than 90 degree, because it's like falling, right? And here we just got rid of this u sine theta as I explained it to you, and this is your point of incident, right? Okay, so let's just and here you can say at point of projection, u of pop, actually u vector of pop is u cosine theta I cap, actually this is your I cap, and u sine theta j cap. So y represents j cap, and your x represents I cap. And similarly you can say like at top, basically at top we are just having the x component, which is u cosine theta I cap, but we are not having any sort of y component, so plus 0. So basically at this point the velocity is u cosine theta I cap plus 0 j cap. Okay, and yeah, these are some things you can just look for. Basically here you are having this vector downward, so that's why we are having some sort of negative in front. So yeah, okay, now let's just talk about time of flight, right? So the time taken by projectile, this projectile, point of between point of projection and point of impact is known as time of flight. So basically the body, like from here, covers this path to here, so the time taken by the body to cover this path, you can say it's the time of flight. That's it. So how we're gonna do that, how we're gonna calculate the formula is, if time taken is t during the motion between points a to b, so s vector of y equals u vector of y times t plus 1 over 2 a vector of y t squared, right? And we have in y direction, we don't have any sort of like, so here we are having s equals 0, right? And wait a second, let me just check this out once. And okay, so like sy is 0 here, it's the net vertical displacement in y direction. So basically this body covers from here to here, and this is your point of, like you can say, what was that was, wait a second, I think point of top, right? Point top of projectile. Okay, so this is your top of projectile. So the path covered by the body here, and then the same path would be covered by the body there. So basically these two cancels out if we talk about a vector. So that's why it's 0, right? So sy is 0 here. So and your ay is minus g. So from this equation you can say your t is 2u sub y over g, which is t equals 2u sine theta over g. So this is your time of flight, that is depending on u, like the initial velocity, and the theta at which the projectile is being thrown, right? Okay, now let's just talk about the maximum height. During the projectile motion, maximum height attained by the object on vertical axis is known as the maximum height. Obviously this is your maximum height, right? So here your u of y is, I'm sorry, y v of y is 0, right? And v of x is u of x, which is u cosine theta. That's the only velocity which is acting at that point, right? So at maximum height vy is 0. So basically from this equation of motion, actually we can say that 0 equals u square minus 2gh. And here we can say isolating h, it's gonna be giving us h equals u sub y whole squared over 2g, and that's gonna be giving us h equals u squared sine squared theta over 2g, right? And h becomes maximum, so greatest height at theta 90 degree, obviously because sine of theta is maximum at pi over 2, right? So basically h is maximum, h max is gonna be u squared over 2g, right? So yeah, when, like, obviously guys, look, when you throw the ball straight like this angle is 90 degree, so then it's gonna be achieving maximum height, right? So that's how you can just take a feel of that. Now let's just talk about the horizontal range. So this is your range, actually, as I just explained it to you, actually, in the equation of trajectory, right? Do you remember, guys? Don't you? Okay, so here we have r equals uxt in the x direction, right? So ux is u cosine theta, so you can plug it back over here, and r equals u cosine theta and t. And now we have, okay, and here we are having t is 2uyg from the time of flight formula. Do you remember? Don't you, guys? So basically we can plug 2u cosine theta, actually this ux, and uy sine theta over g. So it's u squared 2 sine theta over g. And finally we know that 2 sine theta cosine theta is sine 2 theta, actually. So yeah, so basically we're having the range, actually, that is r equals u squared sine 2 theta over g. And again, in order to just have the maximum range, r max, you gotta plug theta equals 45 degree, that is pi over 4, and when you plug that over there, that's gonna be giving us sine 90, which is u squared over g. So yeah, that's how it works, actually. And here it is, actually, r max when theta is 45 degree. And yeah, so there you can understand all the things, actually. Relation between r and h, that is the range and the maximum height, actually. So r is u squared sine 2 theta over g, and h equals this thing, right? So from like dividing these two equations, actually, so r over h equals u squared sine 2 theta over g over u squared sine squared theta over 2g. So that's going to be giving us r over h equals 4 times 4 over tangent theta, which is r tangent theta equals 4h, right? Okay, and I think it's enough, guys, and for this video it's enough. And so for this video, guys, let's just keep this thing from till here, and in the next video, I'm not sure when, but I'll record, we'll talk about these things. But basically I have taught you all the necessary things which are important to understand about the projectile motion till now in this video only. So you don't need to watch any other video, and you just have learned the projectile motion, right? So yeah, Goodbye, guys. Take care. Love you. And just learn mathematics and physics as well if you want. And if you have any kind of doubt so far, you are free to ask me in the comment section. I'll be there to reply over your questions. And thank you for watching this video, guys. Just come up in the next video because I'm just gonna bring a lot of things like this for you. Goodbye, guys. Love you. Take care. Love your life and love mathematics and physics. Woo!